Good day, everyone, and welcome to this session of Programmers Week 2021. Thank you for joining. It is an honor to present for you today. I am Ted Borlongan. I am a Cognizant Softvision principal developer. And to know more about me, I prepared a slide at the end of this presentation. So let me jump right into our agenda for today without further ado. Today, we will talk about the idea behind our topic, looking up the cloud and dream big. And also, we will talk about our project success using cloud technology. And I will show you how to deploy your single page application to the cloud without managing servers and keep it up and running for just a fraction of a cost. We will end the presentation after the question and answer part. So with that, let me begin by telling you a story. I'm always delighted with cloud formations. And what you see on your screen now is a picture I took via mobile phone. And one of the many times I stopped for a moment to take a shot of a relaxing view of my hometown. And I'll tell you why this is important to me. One of the oldest and best ways to see with your imagination is through your beginner's mind. And one way to trigger your beginner's mind is when you look up the clouds and imagine what you see. Before I continue, I'd like to know who among our attendees can relate to this. Have you ever found yourself looking up the cloud while you were thinking about something? I may not be able to see your responses right away, but please feel free to share your experiences through the chat window. While you're thinking about it, let me continue with the presentation. My life during my teenage years was a constant challenge. And whenever I feel like it becomes rough, I would climb up the roof, lie there, and watch the clouds above me as they move. And I imagine different images out of the cloud formations. That was my simple way of coping up with challenges. I avoided bad influences because I let go of my disappointments by spending time close to nature. What you should see on your screen now is my picture from a couple of years ago. So, how is it related to the topic today? By constantly watching clouds, I learned to dream big and establish my goals by making promises that I will never allow my disappointments to ruin my commitment to achieving whatever I pursue. The experience of hardships served as the cornerstone to build a better version of myself as time went by. Excuse me. um, sorry, let me go back to that. Uh, a couple of years after graduation, I forgot about this habit and I became preoccupied with my job and the busy life in the city. Until one day, I met a Microsoft evangelist. This was this was in the year 2012. We had a contact person from Microsoft, and we arranged a meeting with them to know how we could leverage the cloud as a competency. As the solutions architect answered our questions, I became very interested in learning the cloud technology. Suddenly, I got reminded of my old habit of looking up the cloud to establish my goals. During that time, inside a cold conference room, I was dreaming big. But that time, I was not looking at the cloud up the sky, but I was looking up the cloud as a technology platform. It was a turning point for me, and I said to myself, "This is where I want to be. Someday, I will be as knowledgeable as him." And from then on, my quest to learning the cloud never stopped. Starting that day, I knew I wanted to become a cloud solutions architect. And it brings me constant challenge that gives me continuous satisfaction. It is challenging, yet it is rewarding. And I would say one of the reasons why I'm presenting for you today is my constant pursuit of achieving that dream. I've taken several certification exams to enhance and test my knowledge of cloud technology. And yesterday, even on a Sunday, I took the AWS Solutions Architect Professional exam. And in God's grace, I passed. As you can see, it is still cloud, but this time it is not cloud as I used to watch as I lie on the roof, but it's cloud as a computing technology. But what is a computing technology? Or what is cloud computing? Cloud computing is the on-demand availability of computer system resources, especially data storage and computing power, without direct active management by the user. In the following slides and the demo, I'm showing you Microsoft Azure to share how cloud help us achieve our clients' goals. Let me continue the story by sharing our recent project success that became possible because of the cloud. To make things look simpler, here is the 10,000 feet view of the multi-tenant application. Our clients offers email marketing solutions to their customers. They have a template for each marketing campaign, and each customer owns a unique email template. These templates are populated by data dynamically from the database before it gets sent to the designated recipients. What you see on your screen now is the simplified version of the architecture. The process starts when the scheduler service executes on a predefined interval. It would read a table in the database to check the tenants with scheduled run for sending emails. Once done, it will trigger the email engine, and the email engine will pull those flag records. The email engine would query the same database again to get the details related to each recipient, the email template to use, and the additional information required to merge the email before producing the final email. When the email provider successfully responded to the send email request, the email engine will update the specific record in the database to clear the flag so that it will no longer process the same record in the next scheduled run. The email provider sends the outcome of each email process by invoking a webhook that will update a record in the same database for reporting purposes, such as how many recipients opened the email, number of bounce emails, number of unsubscribes, etc., etc. By now, I'm sure you already know what the problem is with this architecture. And to add more stress to the database server, it is also used by other applications. So here are some of the challenges of our clients. First is scalability. As their customers grew, they were starting to lose ample opportunities because they had to reject huge companies requiring sending hundreds of thousands of emails per day just because their legacy architecture couldn't scale. In the cloud, there are two ways to scale your compute resources. One is to scale up, as you can see on your screen now, and it means it's increasing compute resource capacity in terms of memory, CPU, bandwidth, or disk space. And the other one is scaling out, which is basically creating another instance of your compute resources to distribute the load. As you recall in the previous slide, their database became a single point of failure, which means high availability is also one of their concerns. Whenever the system processes around 70,000 emails, it would take an hour or so to execute, and then eventually it would fail. You will see in the new architecture in just a moment that we didn't implement redundancy in our cloud resources. Still, we consider the ability to retry failing events in an idempotent manner, which means resiliency is also being taken care of. And then lastly, performance. This is very important for them. So what are their goals? Their goals are to be able to send 250,000 emails per client per hour, to implement loosely coupled architecture to eliminate single point of failure, to design the application for scalability and performance, to offload tremendous amount of dependency from the SQL database, and to have the capability to execute one-off processing instead of waiting for the scheduler to run. And then lastly, they want to save a copy of each email sent or read it for troubleshooting and auditing purposes. Let me talk briefly about the architecture, and then I will explain each service a bit further. To address the one-off processing, we expose uh, the API through the functionality through App Service, Azure App Service. It hosts the API endpoint, which receives the email data, and we configure the messages coming from this endpoint with a higher priority to process it more quickly than those requests coming from the scheduler right here. So the pattern for this is priority queue pattern. The app service gets confidential information from Azure Key Vault, and the app service will save the email data to the temporary storage, which is Azure Table Storage. It will then send a message to the Azure Service Bus, and we configured a Service Bus queue to subscribe to that topic. So whenever a message comes in, it will publish an event notification to its subscribers, assuming that there are multiple subscribers for this particular topic. But in our case, we only have one, which is the send email service bus queue. And the pattern that we implement for that is a publisher subscriber pattern. We also implemented claim check and a payload to avoid reaching the message size limit of the message bus. So the content of this service bus queue is just enough information for the email engine to know which email data it should pull from the table storage and the corresponding HTML template that it requires. It will pull it from the blob storage. And in the event that the email template required is not available in the blob storage, that's the only time that the system would go back to the SQL Server, pull it from there, and store it from the blob storage again, so that the incoming request or process that utilizes the same email template can just use the existing HTML template from the blob storage. And then to be able to address the need to save a copy of the email sent to the clients, we integrated with a document management service, which uses another Azure blob storage under the hood. As I mentioned in the previous slide, we didn't implement redundant resources, but we can easily do that in the cloud. To perform retries, the email engine uses an error queue to reprocess the failed emails, and after third retry, it moves it to the dead letter queue. To see the overall health of the application, we use Application Insights. And we also configured Azure Monitor Service to send alerts when email failures reach a certain threshold. Let's now take a look at each of these services in a little more detail. First is Azure Key Vault. Azure Key Vault is a cloud service for securely storing and accessing secrets. A secret is anything that you want tightly controlled access to, such as API keys, passwords, certificates, or cryptographic keys. Key Vault Service supports two types of containers. One is Vault, and one is Managed Hardware Security Module. Um, in our use case, we use it as a Vault to hide the API keys and passwords. And then Azure App Service. Azure App Service is a fully managed service with built-in infrastructure maintenance, security patching, and scaling. It lets you create application faster with its one-of-a-kind cloud service to quickly and easily create enterprise-ready web and mobile apps for any platform. Next is the web jobs. Web job is a feature of Azure App Service that enables you to run a program or a script in the same instance as the web app. There's no additional cost to use web job. There are two types of web jobs. One is continuous and one is triggered. Continuous starts immediately when the web job is created. To keep the job from ending, the program or script typically does its work inside an endless loop. If the job does end, you can restart it. A triggered web job, as the name implies, it starts only when triggered or on schedule. As you can see at, uh, at the top, there's a scheduler there. Azure Table Storage is a service that stores non-relational structured data, also known as structured NoSQL data in the cloud. It provides a key attribute store with a schemaless design. And then Blob Storage. Blob Storage is a Microsoft object storage solution for the cloud. Blob Storage is optimized for storing massive amount of unstructured data. And unstructured data is data that doesn't adhere to any particular model or definition, such as text or binary data. And then I put the line in the middle of service bus topic and service bus queue because they are both service bus anyway. Service bus is a fully managed enterprise message broker with message queues and topics. It is used to decouple application and services from each other. And some of the benefits are load balancing, safely routing and transferring data and control access service and application boundaries, and coordinating transactional work that requires high degree of reliability. We already talked about the web job. This is a continuous web job right here. And then application app service, or also known as extensible application performance management. We use it to monitor our live applications. It will automatically detect performance anomalies and includes powerful analytics tools to help you diagnose issues and to understand what users actually do with your app. So what is the outcome of this architecture? Scalable, highly available, resilient cloud application that is capable of sending 270,000 emails per hour. It is designed under a loosely coupled infrastructure and powered by automated build and release process with automated email alerts. So before we continue, does anyone has any questions so far?
We don't have any questions.
Cool. All right. So before we continue with the serverless application demo, may I ask our moderators to please share the link that I've given to access our sample application. And when it is loaded on your screen, guys, please let us know via chat so we can move ahead.
I have shared the link.
Cool. All right, while waiting, let me switch off the AC real quick. All right. Are we ready to continue now?
Yes.
Cool. So in this demo, I will show you how you can stay ahead of the competition on managing spikes in web traffic by seamlessly scaling compute resources in any country or region while reducing costs. All right, so here's the high level architecture of our sample application. So this is just to manage your expectations. This is just scratching the surface. You can explore on your own. You can extend this architecture, but this should be a good starting point for you if you're starting to learn cloud. The first component here is the content delivery network, or CDN. With Azure CDN, you can cache static objects loaded from Azure Blob Storage. It could also be a web application or any publicly accessible web server. And basically, the idea is it brings your website content super close to the users wherever they are. So, for example, somebody from the United States is trying to access your web application for the first time. Um, what happens is content delivery network will identify the nearest location or edge location to that user. It will grab all the files or all the contents of your web application from the origin, which is the Azure Blob Storage in our case, and store it there. So that the next time or the next user that will try to access your application or your website, uh, he or she will experience a uh, very fast response from your application because your application is being loaded not from your origin, but from the edge location nearest to them. And then next is the Azure Blob Storage. We already talked about that in the previous slide. But to tell you more about it, it is also used for serving images or documents directly to the browser. We can store files for distributed access. It can also be used for writing log files. It can also be used for storing backup and restore files for disaster recovery and archiving. And then the new service that we have seen so far in this demo is the API management service. There's a service in there. I apologize. So API management service enables us to control how data and services are exposed to the outside world by applying authentication, authorization, and usage limits. So in our case, I didn't implement the authentication and authorization part. So please feel free to explore that area on your own. And then next is Azure Function app. Azure Function is an event-driven compute on-demand experience that extends the existing Azure application platform with capabilities to implement code triggered by events occurring in Azure or third-party services, as well as on-premise system. In fact, when you deploy an Azure function, uh, it is right away callable through Postman. But the reason why we have API management is that by default it doesn't implement security measures. API management service does that for your Azure function. And then Azure Table Storage. Azure Table Storage is a service that stores non-relational structured data, as discussed earlier. And also we are already familiar with the application insights. So let's go ahead. So in this demo, I'll talk about creating Azure account first, and then create Azure Table Storage, Blob Storage. How do you configure your content delivery network? We will explore the API management service, and then we will learn about the basic of Azure functions, and then deploy the single page application. And lastly, the cost associated for these cloud resources. So with that, let me fire up my browser here. And I will access my Azure portal account, or Azure account rather. All right. So let's talk about creating Azure storage first. So when you create an Azure account, the first thing that you'll notice is you have a global search here. I normally use this. So let's search for the Azure storage account. And as you can see, I already have one there, but let's go back to it later. So I'll create, all right, an account. When you're using a trial version, I'm not sure what appears in here, but there's something that would appear in here. And then resource group. Resource group is just being used to group your cloud resources so that you can monitor the cost associated for all the resources that you provision inside your Azure. And then it can also allow you to remove all the resources that you provisioned related to that resource group. Okay, so let's select POC. And then storage account name is the name of your storage account. Say, for example, Programmer Speak 26. When you choose the region, please choose the region that is close to you. So it will be not expensive. And then I normally just use standard here and select local redundant storage. There's more to this. This has something to do with the disaster recovery. If you're interested, please explore that more. And then review and create. Okay, and then create. So this will take a while. So let's take a look at how it looks like when it's done. All right, here, here's my Programmers Week demo storage account, which I created earlier. Hang on a second. Right. Somebody is blocking my view, so. All right. So the first thing that you want to do, if you want to deploy your single page application, is to go to the storage account and locate this static website here. When you click this, all that you need to do is to click the enable here. When you click the enable, it will give you this primary endpoint. This is the URL that you will configure for your cloud content delivery network. Sorry. So, for example, if you have both a domain, which is, for example, www.programmersweek.com, and you want that to point to your CDN, uh, your CDN is just a caching server, right? Essentially, basically, it also needs a source or origin. So this is the origin of your web files. And here, you just need to specify what's the entry point for your application, and in case of error, what's going to be the error page for your application. And then after you save this and it's enabled, it will create this web with dollar sign here. Now, this is where you should deploy your web files. So let's get back to this, and let's take a look at the content delivery network. So, like the first one, you have a create button here. Resource group, I already explained it. You can give it a name, and then by default, it's global. There's no choice, the other choice there. And what I normally choose here, and I want to point out, is the premium Verizon. I am not sure. Previously, when I was doing this, the custom domain name is only supported in premium Verizon. I am not sure if that has changed since then. So please explore that on your own too. So, but for this demo, I have chosen the premium Verizon. And then here, it says here, create a new CDN endpoint. This is what I'm talking about when I uh, said that the CDN will pull the data or the content of your files from your origin. So, for example, Programmers Week 2021. There you go. So the check indicator there means it is available. And then the origin type is, I want to say it's storage. And then the origin host name are the host name that were automatically created for me when I created that um, storage account. All right, so I'm not going to do that because we already have that here. So let me discard that. So once it's done, what you should see is something like this, and this is the URL that we shared with you. So when we go here, it will pull the records or the content of the sites from the storage and then load the application. All right. As you can see, it loaded up super fast. Not because it's just a static application, but I think some of us already access the application, so it's loading very fast. So here, if I say, uh, if I fill this out and send it, it should send me an email. And 78. You can try it on your own as well if you want. Feel free. But one thing that I want to point out is you will only be allowed to, or actually, I just configured the application to allow sending requests up to 3 times in an hour, if I remember it correctly. So once I submit it, it will redirect me to this page, and I should receive an email anytime soon. See, great. I am not logged into my account. Hang on a second. I'm just accessing my email at the moment. Just bear with me. All right. So as you can see, I already got it. 11:37 a.m. just in. So we are talking about serverless application. We are talking about static web app. But how did it send an email? There has to be a backing service for that, right? So the backing service for that is what we are talking about said when we talk about the application management service or application programming interface management service, API management service, and Azure function. So how does it look like? Let me show you in the source code how it looked like. Still loading up. And here. So it's an Azure function is just a simple function here. I have on registration receive function. This is just one function. One function. Um, the only difference for in here with a traditional function in C sharp, for example, because C sharp is my language here, is this annotations. So it's here. It says when I deploy this code, I want you to give this a name which is on registration receive in the Azure environment, and I want this function to be triggered via HTTP request. And once I'm done with this, I want to notify the downstream, which is table registration or the table storage. So basically, this is the input binding. This is the output binding of your Azure function. So when you deploy that, let's see. I'm not going to deploy that, but if you want to deploy that, you can publish and log into your account and publish that as an Azure function. Right? Okay. So it's already there. Let's go back and take a look at the function app. So I have a function app which when I open up, I should see a function with a name on registration receive. When you go in here, um, you should see code and test. To test it out, or you can go to the integration section, which basically shows the output of the attributes that we already set. So as I mentioned previously, this is not a secure way of exposing your function. It automatically generates the function URL, which you can invoke via Postman, but it is not the advisable thing to do. What is advisable is that you can create API management service. So this time I already have it. In the interest of time, I will not show you how to create that. I think that's straightforward. But one thing to note is that it it requires you to have a subscription. So when you create a subscription, you need to configure this to your client. In my case, it's a React.js application. When I send the post request, I need to populate the uh, uh, subscription information in the header. I made the source code for both front end and back end available in GitHub. I will show it to you later. And then here in the APIs, um, I have here a registration serverless API, which is pointed to the Azure Function app that I created. So through this, I am able to uh, modify the behavior of my function app. So let's see. Oops, sorry. Start. Let's see. Okay. So here, um, you have the ability to modify the behavior of your request. So inbound processing, you can implement policies there. Uh, Before you send the response to your clients, you can also modify there. I'm looking for a particular, there you go. So I modified the rate limit here. Let me open that up. Okay. I modified the configuration or this application management service to only allow the requests coming from this URL. So if you're familiar with cross-origin resource sharing, this is what it is. So basically, this one is pointed to the CDN URL, and this one is pointed to the URL generated by our static web application from the Azure storage account. And then allowed post, get and post, and is that okay. Rate limit calls. So 5 calls every 60 every minute. I think it's a seconds. So I thought I configured that to 3 requests per hour. So I'm wrong. It's 5. So that's actually pretty much it. And then we've talked about Azure App Insights as well, application insights. Okay. And we requested you to go to the application before we proceed to the demo. And the reason why we did that is for us to be able to see the events. So here, when you create an application insights, you will be given a instrumentation key, and that instrumentation key is what you will use in your front end application or in your back end application to communicate with this application insights. So look at that. From India, we have 199 participants in this call. Philippines, 1,000. Wow, I'm so impressed with the numbers here. Japan, 175. Singapore, 84. Malaysia, wow. This is an overwhelming figures, guys. Thank you very much for joining this session. So I think that concludes our presentation for this demo or for this session. And let me go back to the presentation to show you more about our slides. So even though we configured our application in a uh, serverless manner, be mindful of the service limits because it is related to the um, plans or subscription plans that you avail. Um, and this URL here, this link here provides you, oops, sorry, provides you the complete details around that. And also, we don't have time to talk about the best practices, but one of the best practices that I would say is if you feel like um, you need more security because your application, even though it is a static application, contains sensitive information, you can take a look at implementing web application firewall. Web application firewall is application gateway, in other terms, in Azure. You can bind it with the content delivery network here, or you can bind it in the API management service. So something to look forward to. And then I made the, like what I said, I made the source code available in this GitHub. After this demo, I will update the README file so you'll be guided how to configure that on your local machine. What are the services that you need to create and how to go with that. So, but the codes are already there if you want to take a look. All right. So I think it's time for question and answer.
Yes, we do have a question.
Yeah, sure.
It says, with a robust and highly scalable architecture, you presented earlier, what are some of the challenges that you faced in development and testing?
In development and testing?
It? Yes, how do you resolve it, if you can share?
Oh yeah, sure. So one of the challenges is that it has to be available in the environment, right? So there are times that we needed to create stub endpoints for the testing, and this is for some of the process that requires like or involve cost in doing so. But majority of the time, we are testing against an actual environment, and the challenge there was when we were testing it, the application was performing so fast that the downstream resources became a problem. So we are integrated with a email provider, and the next thing that we we knew was we were blocked. Our access were blocked by the email provider, and when we contacted them, they said, "Oh, we identified a like unusual activity in your account, and that's affecting other users that we are serving. So we temporarily disabled your account. Please let us know, if in the future you'll be testing this, and so we can coordinate when is the best time to do that." So I think that's one of the process that I can remember. That's one of the challenges. It's always a challenge if your downstream process cannot uh, cope up with the highly scalable architecture that you implemented.
Thank you. We have another one.
Yeah.
What is the preferred language for writing Azure functions?
I believe it is supported for the supported languages, sorry, are Node.js, .NET Core. I'm not sure if Python is also supported. AWS and Azure is mixing in my head right now, but you can check that out. One thing I'm sure about is Node.js and .NET Core.
Thank you. Another one is, will CDN reduce cost?
Yes, definitely. Because if there are services in the cloud platform that actually cost you when you transfer data from, especially from one region to another. And if you have CDN already cached with your content, then you are paying the minimal monthly fee for the CDN instead of the transfer fee from getting your resources from the origin.
Thank you. And then last one, and then we have to wrap up.
Yeah.
You mentioned about the SSL certificate. Since we could not see it because we don't have a custom domain, can you explain how it works?
Okay. So SSL, actually, yeah, we weren't able to see SSL because it will become available once you configure your custom domain. So the idea behind SSL is that uh, you would purchase a certificate from a legitimate certification authority, and certification authorities are just few in the world. So when you have the certificate coming from them, the client machines are actually uh, uh, sure that you're presenting them the right or the valid certificate. And how it works is that first, if you go to the browser, you can see a padlock there in the URL. You can check the issuer and or the certificate information if the certificate really belongs to the that domain. So that's one way of knowing whether you are in a phishing website or on a legitimate website. And that's the first part of it. The second part is it allows secure communication between the client and the server. And when I say by that, what I mean by that is first when we request something from for example, we go to cognizant.com. So our client machine talks to the cognizant.com server. What happens is it would say, hello, these are the encryption algorithms that I support. These are the compression methods that I support. So please choose one of this. Um, um, and then the server then would respond, hello, this is the encryption algorithm that I've chosen, and this is the, let's use this compression algorithm. Along with this is the certificate that was given to me by my certification authority. And this is also the public key that you can use to encrypt our shared secret. So sorry, it's a mouthful, but uh, the process is called SSL handshake. You may want to check that out. So the idea is first initial calls or initial communication between the client and the server using SSL is uh, asymmetric, and then once the client gets the public key, it will encrypt the shared secret so that uh, the succeeding requests between the requests and responses between the client and the server is being done in a symmetric encryption. So I yeah, you can check that out. SSL certificate, SSL handshake. So for more information. All right.
Thank you, Ted.
Sure.
That's it. And we have a lot of messages thanking you for the great presentation.
Cool. So like what I said, I provided a slide here to know more about me. If you have more questions, reach out to me. I think via LinkedIn because we have a BC email here. So I just want to make sure that I'm not missing important emails. Please reach out to me via LinkedIn. And lastly, Um, I'm not sure if, yeah, I mentioned about this as well, right? And lastly, for the closing remarks, I, um, I would say, I want to encourage you to learn cloud today. When we say we don't have time, we will never have time. Because the truth is, you can never manage time. You can only manage yourself. That's it for this presentation, and thank you very much.